So this is week 33 quiz, and number 2 says let x and y be two-digit integers such that y is obtained by reversing the digits of x. The integer x and y satisfy x squared minus y squared equals m squared for some positive integer m. What is x plus y plus m? So let's set x as like AB, and I drew a line at the top because it's representing digits, not multiplying. So that means that y is just BA. So AB plus BA, we know, has to be an integer, has to be a multiple of 11, because let's take an example here. For example, if we have like 21 and 12, if we add together, we get 33, because A plus B is the ones digit, so, and it's just 10A plus 10B. 10A plus 10B is the tens or hundreds. So basically, if we have these singular numerical digits, we have just 10A plus B plus 10B plus A. We get 11A plus 11B, and since we know A and B are integers, that means that this is divisible by 11. So if we know that x plus y is divisible by 11, that means that we're trying to find x squared minus y squared equals m squared, and we use difference of squares, so we get x minus y times x plus y equals m squared. And since we know x plus y is divisible by 11, we can see that either this is 11 squared or this is 11, and this is also divisible by 11. Because this cannot be divisible by 11 cubed, because that's 1331, and these are only two-digit numbers, so therefore it cannot be large enough to exceed 11 squared. So we can try to see what x minus y would be, so that just be AB minus BA, which is just 10A plus B minus 10B plus minus A, and we get 9A minus 9B, which we know is divisible by 9. So if we know this is divisible by 9, it cannot be divisible by 11, because if it's divisible by 11, that means that x would have to be 99, and y would have to be 99. And we know we can't have these two be the same, because m has to be positive. So therefore, we know that x plus y has to be divisible by 11 squared or 121. So now we can start like listing some possibilities for x. And since we know that x is greater than y, because positive integer and x squared minus y squared, we can start. So we need x plus y to be divisible by 11 squared. And so if we have like 92, we have 92 plus 29, 91. 91 plus 19, which is, it's 92, and then 92 plus 29 is 11, and then this carries a 121. So now we have 92, and keep adding 1 and subtracting 1. 7, 6, 5, 3, 4, 5, 6. This does not exist. And we can see that for whatever integer we have, it's just 92 minus 29 squared, for example. Then this is just equal to 92 minus 29 equals to 63, which is divisible by 9, and 92 plus 29 is 121. So if we multiply these, we get, why is my breaking? So if we multiply these, we get 63 times 11 squared. So we do the multiplication and we get 7723. Sorry, let me reach. Oh no, sorry, 7623. And we can take the square root of this, which is just equal to a. Sorry, if we take the square root of this, it does not equal a positive number, I think. So if we check with the calculator, 7623 and the square root, yeah, you can see that does not check out. And so therefore, it cannot, what happened? Oh, sorry. Uh, ignore that, please. So we can see that we cannot have 92. And so let's try 65. So 65 plus 65, 65 plus 56 equals 121. And then 65 minus 56 equals 9. And so 9 times 121 is just 1089. And the square root of this should be 33. We can check with a calculator. Yeah, and square root of 1089 is 33. And so the answer is just 65 plus 56 plus 33. Now, note that you're like not supposed to use the calculator for this, but I was trying to like prove to you that my calculations were correct. So like, yeah. And the answer is just 154. So the answer is just 154.